Accelerated Math 7-8 students. This is Module 12, Lesson 14, and it is called Dilations on a Coordinate Plane. Dilations on the coordinate plane. Now, we've been working with this a little bit with trying to figure out examples of dilations when you have to use the coordinate plane to figure things out. So we've had a few conversations about it, but we're going to focus on it a little bit more today. The goal. Today we will describe what dilations do to figures on a coordinate plane. Question I want you to be thinking about while we're doing this lesson is, how do you apply a dilation to a point or a figure on the coordinate plane? Okay. So figure this out. It says the point A, 7, 4, is dilated from the origin by a scale factor of 3. What are the coordinates of A prime? So the thing that you have to keep in mind that is very, very important, and the reason that we know that it's very, very important is because I underlined the word origin. As long as your center of dilation is the origin, then there is a very distinct and easy way to figure out the coordinates without even having an order or a coordinate plane to figure it out. So as long as they're telling you that the center of dilation is the origin, then all you do is you take the ordered pair of the point in question, so this is point A, and when it gives you the scale factor of 3, all you have to do is take the ordered pair and multiply it by the scale factor. Okay, so we would take 7 times 3 equals 21, and we would take 4 times 3 equals 12, and so these two coordinates now tell us the coordinates for the dilated image. So we would know that A prime equals 21, 12. So on the coordinate plane, you would go to the right 21 and up 12, and that would be where A prime sits. Okay? So the most important thing that I can tell you and that you have to remember is that as long as the point or the figure or the segment or whatever it is being dilated from the origin, then you just multiply by the scale factor. And this works for everything that you're going to work on. So let's take a look at what happens when you have a figure on a coordinate plane and see what we can come up with. Triangle ABC is dilated from the origin. Aha, there's the magic word, dilated from the origin by a scale factor of 1/2. Okay, so that's important information. Where would the triangle A prime, B prime, C prime be? Okay, so as you noticed, every point needs to be dilated. Okay? In the past, we've always left the center O if it starts from the O and it goes somewhere. We've never actually dilated the O. But because all the points on the triangle are part of the triangle that is not sitting on the center O, all of them must be dilated. Okay? So you have to show some work for this. So if we have triangle ABC, and I'm going to write the points like this, because what we need to do is we need to list out the ordered pairs of each point. So we know that A sits at 3, 4. We know that B sits at -7, 2. And we know that C sits at 2, 2. Okay? Those are the locations of the 3 points. So in order to dilate it correctly, we now have to take those points, because it's being dilated from the origin, we need to multiply each one of those points by 1/2. So I'm going to take 3 times 1/2, and I get 3/2. Okay? I'm going to take 4 times 1/2, and I get 4/2. I'm going to take -7 times 1/2, and I get -7/2. I'm going to take 2 times 1/2, and I'm going to get 2/2. Okay, and those can be simplified even more. Okay, so 3/2 simplifies to 1 1/2, 4 halves simplifies to 2. So this now is going to be my A prime. Okay, so now let's look at -7/2 is going to be -3 1/2, and 2/2 equals 1. So that is going to be B prime. And we just did 2, so we know that 2 divided by 2 is 1, 2 divided by 2 is 1, and that is going to be C prime. So now we know the locations for our image. This was our pre-image. This is our image. Okay, so then what you have to do is you actually have to plot them on the graph. So A prime is 1.5, so I go to the right 1.5 and up 2. So my new point A prime is going to be here. Okay, now my second point, B prime, sits at negative 3.5, so I go 1, 2, 3.5, and I go up 1. So this is B prime. Okay, and then C is I go to the right 1 and up 1, and that is C prime. And then you connect them, and lo and behold, you now have triangle A prime, B prime, C prime. Okay, and that's how you do it. Very simple, very easy. The only thing that I could see us getting bogged down with is that if you have a figure that has multiple points, then you're going to have to figure out what the new point would be by applying the scale factor for all of the points. And that's where some kids get frustrated because it takes a long time. But the skill itself is not difficult. The skill is very easy to do as long as you remember what you're doing. So remember, when you have a scale factor, you take the original and you multiply it by the scale factor, and that gives you your image. So you take your pre-image times the scale factor, and you get your image. Okay. If you were given the image and you were trying to determine the pre-image, then remember you would have to do an inverse operation to figure that out. Okay. All right, so let's go back to our goal. Our goal for today's lesson was, today we will describe what dilations do to figures on coordinate planes. Okay, obviously this one that we have on the coordinate plane is an example of a reduction, and we know this because the scale factor was 1/2. The question that we posed at the beginning of the lesson is, how do you apply a dilation to a point or a figure on the coordinate plane? The way we do that is we take the scale factor and multiply it by the original coordinates. Okay? And that's all I have for you today. We're going to have lots of practice in our packet when you get to school tomorrow. All right, I'll see you all then. Bye.